This is video number 4 on revision for the chemical world topic on atoms, elements, and the periodic table. We'll look at chemical equations and word equations in this video. So let's look at acid reactions. So acids can react with things like bases to give you salt and water. They can also react with a metal to give you salt and hydrogen gas. They can also react with things called carbonates to give you salt, water, and carbon dioxide gas. You need to commit these to memory. You need to know what. So the reactants in this case are on the left-hand side of an equation. Arrow means to recombine to make. Okay, because whatever you have on the left, you have to end up on the right. Atoms can't be created or destroyed. They can only be rearranged in a chemical reaction. So the plus means react, right? So if you mix an acid and a base, you'll get salt and water. Acid metal, you get salt and gas. Acid carbonate, salt, water, carbon dioxide. Easy trick with this is to just think of the fact that all of these have a salt in common. Okay, they all form salts at the end of the day. Let's look at acid-base reaction, also known as neutralization. Neutralization because the salt that's formed in the water is neutral. Okay, pH, if you recall, power of hydrogen, measures the acidity or measures how acidic a substance is. Okay, the pH scale goes from 0 all the way through to 14. It's just a number system. pH of 0 to 6, that's an acid. pH from 8 to 14 is a base. And a pH of 7 is neutral. You need to know these. You can use things like indicators, like litmus paper. These turn color when you expose them to an acid or base. So red litmus paper, just a strip of red. It's a chemical, okay, on paper. Acids make litmus paper turn red. Just think of red for acid. And bases make litmus paper turn blue. Red litmus paper, I should say, turn blue. And vice versa. If it's blue litmus paper, an acid will, I should say that acid is still red in blue litmus paper. Blue litmus paper, they stay blue. So let's do an example. Textbook example, most common example, hydrochloric acid plus sodium hydroxide. Okay, this is an acid base. We've got an acid, the base is the sodium hydroxide. Bases typically contain hydroxide in them or oxide. How do you name the salt? Well, it forms a salt plus water. Should be a revision, hopefully. Salt is made of a metal and non-metal. By definition, it's an ionic compound. That's what salts are. Ionic compounds are made of metals and non-metals. The metal in the reactants here is sodium. So you write sodium first, that's the rule. You always write the metal first. The non-metal comes from the acid ending, which is chloride. You replace the chloric with chloride. And that's it. That's how you name the products. So you name the salt, sodium chloride, and you write water. That's an example of a neutralization reaction there. In terms of chemical symbols, hydrochloric acid, you have to memorize this. It's HCl. H for hydro, chloric is Cl. Okay, hydrochloric acid plus sodium hydroxide. You write the ions first. Sodium is Na plus 1, it's in group 1. Hydroxide is OH minus 1, if you recall. It's a polyatomic ion. Makes sodium chloride. Once again, sodium is Na plus 1. Chloride is Cl minus 1, chlorine. Plus water is H2O. H2O. The 2 is small, remember? It's a subscript. Then you tidy this up. That was the hard bit. Let's tidy it up. HCl plus NaOH makes NaCl plus H2O. Plus 1 and minus 1 cancel out. when you stick them together. Okay, same thing on the right. This equation here is balanced. I'm not going to try and balance it because there's the same number of hydrogens. There's 2 on the left, 2 on the right. Chlorine, there's 1 on the left, 1 on the right. Sodium, there's 1 on the left, 1 on the right. And oxygen, there's 1 on the left, 1 on the right. It's an example of a neutralization reaction, acid-base. Let's do an acid-metal reaction. Let's do sulfuric acid plus sodium metal. That gives you salt plus hydrogen gas. Okay, if you chuck any metal in acid, just think of a gas forming. Okay, bubbles, that's hydrogen gas. That's what you see. Let's name the salt. Remember, this is a metal and non-metal. Metal goes first, non-metal second. Let's now write the chemical symbols. So sulfuric acid, you need to know this. It's H2SO4. Just think of sulfur. Acids contain hydrogen. Okay, it's another way to know this. Sulfuric acid. Sodium is Na. So using the periodic table for sodium makes sodium, that's the metal, sulfates. Non-metal ending. Non-metal comes from the acid ending. Sulfuric becomes sulfate. Sodium is Na plus 1. Sulfate is SO42 minus. It's a polyatomic ion. Plus hydrogen. Hydrogen is H2 if you remember. Let's tidy it up. H2SO4 sulfuric acid plus sodium Na makes Na2SO4. The 2 goes down if you remember. The 1 doesn't. Plus H2. Okay. Balancing it, let's take a list from left to right. H element is hydrogen, sulfur, then oxygen, then sodium. Same thing on the right hand side. Okay, in the same order. There's 2 hydrogen on the left, there's 1 sodium on the left, 4 oxygen on the left, 1 sodium on the left. Hydrogen, there's 2 on the right. Sulfur, there's 1. Oxygen, there's 4. Sodium, there's 2. Sodium, we need to balance that. How do we turn the sodium, the 1 into a 2? You times it by 2 to get 2. And that 2 goes at the front, and that's it. It's balanced. Let's do an acid carbonate reaction. Let's do calcium carbonate plus nitric acid. Okay, write down the products. You get salt plus water plus carbon dioxide. Here's how I think of it. She went crazy. SWC as a memory device. Calcium carbonate. Calcium is Ca. It's in group 2 plus 2. Remember, these are all made of ions, okay? Carbonate is CO3 minus 2 plus nitric acid. You need to know this is HNO3. It's got nitrate in it. Makes the salt. The salt is metal plus non-metal. The metal is calcium. Non-metal is nitrate. Nitric becomes nitrate. So calcium Ca plus 2, nitrate NO3 minus 1, plus water is H2O and carbon dioxide is CO2. Let's stick them together, tidy it up. CaCO3, the plus 2 and minus 2 cancel, plus HNO3 makes CaNO3, brackets around that, and 2. The 2 comes down from the calcium, the 1 doesn't, plus H2O plus CO2. Let's balance it. Calcium, carbon, oxygen, hydrogen, nitrogen, same thing. Let's count. 1 calcium, 1 carbon, 6 oxygen, 1 hydrogen, 1 nitrogen. Calcium, 1 carbon, 1 oxygen. There's 3 times 2. That's what the bracket there means. 6 plus 1, 7 plus 2, 9. Hydrogen, there's 2. Nitrogen, there's 2. Okay, N, there's a 2. There's a whole bracket around the NO3 and the 2. So it's N times 2, which is 2. Let's balance this thing. It looks a bit complicated. Not to worry. Step by step, let's figure out what to do with the... So the hydrogen, let's do the hydrogen first. Looks easier. So turn this into a 2, times it by 2. Put the 2 out the front. This fixes the nitrogen problem because there's 2 nitrogens here. Cross it out, 2. This also fixes the oxygen problem because 2 times 2 lots of 3 is 6. 6 plus 3 is 9. So simply putting a 2 here fixes everything. Okay, so to summarize, you need to know these common acids by heart. Hydrochloric, HCl, H for hydrogen, Cl for chlorine, nitric acid, HNO3, nitric comes from nitrate, the NO3, sulfuric acid. This is H2SO4, sulfuric comes from sulfate. You need to know hydrogen. It exists as a diatomic substance. Diatomic means there's two atoms, H2. Carbon dioxide is CO2. Just think of CO2 emissions. Okay, that means carbon dioxide. And water is H2O. That's the main take-home message.